Hello, Batona Bagaduze. Round 2, we back at this equation thing of the circle. Straight up again. Let's go straight to it. This is a question. It's found on page 193. It's page 193 of the platinum. So we're using our platinum very nicely. So we're gonna use. It's a question number 2. So it goes something like this. What I did is, yes, I took the equation there, and then I'm gonna work with that one. So you're given an equation, determine the equation of a tangent to the circle. This is at the y-intercept. The important thing, this will be at the y-intercept. So first, we must find the center of this radius. So obviously, we said we're gonna add something squared on one side, add something squared so that we can square this, because this one has already been squared for us. We must square this part. So we square that, so we drop this. So this is the 2, this is the 2, and then drop that and that. So we've already covered this part in our last video of how to complete the square and the circles. So after doing that, we can see our center, change the sign, and then the center will be somewhere here. So this will be my circle there. Then now, what is important with this circle is, they said find the equation of a tangent. The tangent will be at the y-intercept. So obviously, this is my y-intercept, because that's where the graph cuts the y-axis, and I've got 2 of them. So since there's 2 of them, it means I'm going to have 2 tangent. There's a tangent that will come here, like this, cutting there. Then there'll be another tangent also going like this, something like that there. And then obviously what you notice, these tangents will meet. But that's another story of altogether, because we know tangent from the same points. Remember, they're equal, but that's not what we're doing here. Then for y-intercept, my x must be 0. So simply put, we're going to substitute 0 for x. So if I substitute 0 there, so this would be 0 minus 5 squared, that's that. Then that would be 25 over 4. Transpose this thing this side. This plus this minus this gives us the 8. Then we can factorize this out. We're gonna get minus 2 and minus 4. So that's 0 and minus 2 and 0 and minus 4. So obviously the minus 2 will be here, 0 and minus 2. So our first y-intercept. This is my other y-intercept, 0 and minus 4. And when that is done, it becomes easier now to find the equation of the tangent. So this one, obviously we can connect a radius there, so that it will help us to find the gradient of the radius. But the radius is always perpendicular to the tangent. Then we'll be able to get the gradient of this tangent. We can call it 1. And then also the same thing will happen here. Okay, let's do that one first. So for the first tangent, we have the coordinates of the center. And then we have the coordinates of that point there, which is 0 and minus 2. So looking at your gradient of the radius, y2 minus y1 over x2 minus x1, you're going to get minus 2 over 5. And since our radius is perpendicular to the tangent, substitute the radius here. Then to get this, so obviously you'll times by the inverse, the negative 2 over 5 here, times by the negative 2 over 5 there. Then our, the inverse will be 5 over 2. So if over here it's negative 5 over 2, then this will cancel all of that. Then the gradient of the tangent, this time this is that. So you have the gradient of the tangent. Then we go to y minus y1, m into x minus x1. We use the coordinate where the tangent cuts. The tangent cuts at the y-intercept, so we use it as x1 and y1. So substitute this one, negative times negative is positive. 0 times this is just 0. This time this is that. Transpose this. You got the first tangent. Going to the second tangent there, we can draw a radius from here to here. A radius, so we can find the gradient from here to here, the gradient of this radius. And then this is another tangent, so we can call it tangent number 2. So this is our gradient. We can find the gradient of this using the gradient of this radius here. We can use the gradient of this radius. Same thing would happen. We have the coordinates. So we're going to have the center, the gradient of the radius. What I did, I said y2 minus y1 over x2 minus x1, we get this. Substitute this one in the gradient of the radius to find the gradient of the tangent, again times by the inverse, 5 over 2 times by 5 over 2. This time this is that. Then the gradient of a tangent will be that. Then use the coordinates where the graph cuts the y-intercept, which is 0 and minus 4, x1, y1. So y minus y1, negative times negative is positive. We have the gradient. M into x minus x1 is the 0. Then we have the gradient of the equation of the tangent. That's how easy, guys, it is to find the equation of a tangent. If there's 2 points, it will cut it 2 points. If it's 1 point, it will cut it 1 point. We have one equation. So now you can be able to do our next exercise on platinum, which is exercise 3. I'll send it on the group. Sure.